In this scenario, we are looking at a 5,000 square foot server room protected by a nitrogen-supplied Oxeo system. Let's start by talking about the main components in an Oxeo system. The Oxeo system is a delivery method for a fire suppression system that currently uses the inert gases, nitrogen or argon, to displace the oxygen in a room, therefore extinguishing the fire. This inert gas system is supplied by 45 80-liter tanks pressurized to 4,500 psi, secured in a customized racking system. This specialized racking system is part of the system approval. The unique valve on the top of each cylinder allows the tanks to be opened simultaneously when the system activates. Per NFPA 2001, a gauge to monitor the tank pressure will also need to be installed on the valve. The master cylinder will have an electric actuator on top of the cylinder valve. When the electric actuator receives power from the alarm panel, the system will activate. Also attached to the master cylinder valve will be the electric actuator monitor switch. This switch monitors whether the electric actuator is currently attached to the cylinder valve or not. If the actuator is not attached, the panel will have a supervisory warning. On the last cylinder, there will be a pilot pressure relief valve that vents excess pilot pressure to ensure the pilot line tubing doesn't rupture during system activation. The extinguishing agent from the cylinders discharges from the tank valve through the flexible hose into a high-pressure manifold designed to withstand a maximum working pressure of 8,000 psi. The pressure relief valve located downstream of the discharge manifold will operate if the manifold is overpressurized. Following the pressure relief valve is a pressure-reducing device that will lower the discharge pressure to enable the use of Schedule 40 ASTM 53 seamless pipe and Class 300 fittings for the remaining pipe network. Specialized VN nozzles are used to mix the extinguishing gas with the room air uniformly and lower the oxygen content in the entire room. Without the turbulence added by the gas nozzles, only pockets of very dense gas would form, which may not extinguish the fire. The detection device used is an air aspirating system that detects fire by sensing smoke particles in the air. In a scenario where a fire has started in the server room and begins to smolder, the smoke will rise and be pulled into the air aspirating sensing piping. The smoke will travel back to the air aspirating device, and once the required threshold of 75% smoke obscuration has been detected, the air aspirating device will send an alarm signal to the ARC100 addressable alarm panel and put the system into the alarm state. 2 alarm signals will be required for extinguishing agent discharge. The first alarm signal has put our system into the alarm state, which you will be able to tell by the pulsing tone from the horn inside the room. As the smoke density increases and passes a second threshold of 100% smoke obscuration, the air aspirating device will send the second alarm signal. This will complete the cross-zone sequence to the ARC100 alarm panel and will set the system into the pre-release state, which will be made apparent by the more rapidly pulsing tone from the horns inside the room. The strobes inside the room will also activate during the pre-release state. As soon as the pre-release state starts, a customized pre-programmed countdown before extinguishing agent release, in this case 30 seconds, will begin. This countdown can be postponed with an abort switch. After releasing the abort switch, you will have 10 to 30 seconds, depending on what the AHJ requires, to leave the room. During the countdown timer, our shunts will be activated. The power for our servers will be turned off, the room's cooling systems will shut down, and any applicable dampers or doors will close. Once the countdown completes, the system will enter release mode. The horn will be a solid tone, and the strobes inside and outside of the room will be active. The panel energizes the actuator on the master cylinder, which causes all cylinders in the system to activate in an instantaneous chain reaction. The gas is pushed through a pressure reducer to lower it from approximately 4,350 psi to approximately 853 psi. These pressures will vary from system to system. The extinguishing agent will quickly travel through the piping network and be expelled at the nozzles. While the room is being pressurized, special air pressure relief vents in the room will open to release the displaced oxygen and prevent damage to the room. 95% of the contained extinguishing agent must fill the room in less than 2 minutes. The agent will dilute the oxygen in the room to a level where the fire is no longer sustainable. The fire must be extinguished 30 seconds after the completed discharge. The room must maintain 85% of its design concentration at the highest point of its protected content for 10 minutes to ensure that the fire is out. After at least 10 minutes have passed, the room can be vented either by a venting system or the fire department. After the area has been vented, it is safe to enter.